Which is faster in Python, while loops or for loops? Most developers have a gut feeling, but today we're settling this with bytecode analysis. We'll run 1 million iterations to see the real performance difference. Spoiler alert, the winner might surprise you, and understanding why will make you a better Python programmer. Let's start with the basics. Here's a while loop iterating from 0 to 9. It needs manual counter management. Initialize, check, increment. Now look at the for loop doing the same thing. Cleaner syntax, no manual counter, using Python's range function. Both produce identical results, but the question is, what's happening under the hood? Here's where it gets fascinating. The while loop generates load fast to check the counter, compare OP for the condition, binary ADD for incrementing, and store fast to update the variable. That's 4 major operations per iteration. The for loop, it uses getIter to create an iterator once, then for iter on each iteration. The Iterator protocol handles everything else. Fewer operations, less overhead, more efficient. Time for our million iteration showdown. First, the while loop. Watch the timer as we count to 1 million with manual increments. Now the for loop with the same range. The results are clear. While loops complete in 0.18 seconds. For loops, 0.13 seconds. That's roughly 28% faster. The for loop wins, and it's not even close. So why is the for loop faster? It's all about iterator efficiency. Python's iterator protocol is implemented in C and highly optimized. Manual counter management in while loops involves more bytecode operations and Python-level arithmetic. For loops also benefit from better CPU cache utilization since the iterator pattern is predictable. This matters most in data processing, parsing large files, or any scenario with nested loops. Here's the practical takeaway. Use for loops by default for iteration. They're faster, cleaner, and more Pythonic. Use while loops only when you need complex conditions, indefinite iteration, or custom increment logic. For example, reading until end of file, waiting for user input, or implementing algorithms with non-standard progression. Don't use while loops just to mimic C style for loops. That's a performance trap. For loops beat while loops by 28%, and now you know exactly why at the bytecode level. Choose for loops for iteration, while loops for complex conditions. If you want to see more, like and subscribe.